All right. So in physics, there is a topic that is in grade 10 that we did, and that topic is called the simple machine. This topic is very important in the sense that mostly it comes by exam, like that. So now we're supposed to understand what a simple machine is. So this is physics in short. We're not supposed to have physics today, but for the sake of others, maybe because you are behind, so we decided that maybe we just have physics there. So now physics, according to what we did, what we said, what a simple machine is. We know what a machine is. Therefore, what does a machine do? For example, I want to open a bottle. For example, a Coca-Cola bottle. I can use an opener. Therefore, very good. So that means that is a machine that I'm using to open the bottle top of a bottle of Coca-Cola. Apart from that, I've got a 50 kg bag of cement. It's either nizatuika pamutu or nipape, or I use what? A wheelbarrow. Now, which one will be easy there? Is it kuipapa, kuitwika, or using a wheelbarrow? Very good. So most of us, we know that the definition for a simple machine, according to some, the simple definition of a simple machine, but mostly I discourage using this definition. So we say this is a device which make it working easy. A simple machine, it is a device which make work easy, but I discourage this one. So the definition that you should use is a simple machine. Okay, a simple machine is what? A device by which and what? Effort. By which an effort is what? Used to overcome the what? The load. Simple as that. What is the load? The load is a point at which an object is what? Raised. What is the effort? It is a point at which a force is what? Applied. So that means that if you are a wheelbarrow, maybe like this, maybe. Huku ukwamene mumagwirira kuja ndiye kuchani ku effort. Apa pamene matengera vintu ndiye pachani pa load. Ukwamene kuzungurukira tire ndiye kuchani pivot. So a pivot is a point of what? Support. What supports this machine is what? The pivot. Once apa tire papamba kuchukumu. Can you be able to kuyenza bwino? No. It means you'll be applying more. That means that is that machine going to make your work easy? No. It makes it now harder. Why? Because apa spavende. What is it? So the other machine that we have is a scissors. Okay, a scissors is in this manner. Okay, How many scissors? So ukwamene mangeneza bimbo ndiyo kushani effort. So the effort is a point at which a force is applied. Always pamene ikuchana kandiye pachani a pivot. Then ukwamene musta you are cutting nyula ukwamene mafaka ndiye kuchani ku load. Sometimes the question come kana kukasoka question pa midafloid. Wapana kupaka pachapani pa point x apani pa y apani pachani z. Na kama the diagram shows a simple machine. What is point x, y, and z? So x is what? The load. This is what? The pivot, and this is what? The effort. So they are what you call even classes of what? Machines. And one of the classes of machines now, the simple machines are made. One of the classes of machines is what you call what? Levers. Levers, hammer, wheelbarrow, all those, even scissors is part of the same levers there. Then apart from that, the second class of machines is what you call a pulley system. The pulley system. The pulley system has got the wheel upper. So then from there we're going to have something which is like this. Then upper, then load. Load to be here, and then ukukuli kantambuza chani effort here. So then kantambuka kwenda so kenamuka ropo kakwenda so like this. So this is what you call the pulley system. Apart from the pulley system, we've got a system called what? We've got another machine called what? Gears. Okay, gears hapa, there will be a driving gear and what, a driven gear. So it's a number of what teeth hapa. Then we go to solve it again. Okay, so ienda huku, ienda the other side here. So that means that there is what you call a driving gear and what a driven. So this is a driving what gear, whereas this is what a driven. An example ututwamu nkolo especially my analog watches ayapa chikupa pacha kulikacha kama seconds kaja kangati kavendeza kama chani kama minutes sivyo kama minutes kazavendeza kama chani kama hours kaja ngati kavendera can the others be moving? No. And then these are called what? Teeth. Not the teeth is Then the fourth one is what you call what? Inclined what? Plane. Inclined plane. Okay, there's another one which is called inclined plane. Other inclined plane imangala so abakatente muka kabwela so, and then kabwela so mean that apa bazakala the distance moved by the what? Load yapa the dl. While is apa bazakala chintu apa, then you're applying the effort going this side. That means that from there up to upper pansi, this is the distance moved by the what? Effort. In distance here effort, or is in distance here chani yellow. Excuse their load. So this is another type of machine. And then what you call the wedge, there's the wheel and axle, which means yama steering ka wheel, then axle, it is fixed at a certain point. Those are also other types of machines there, but I'll give you I'm just giving you to my points there. Now, the other part that I want to explain is under the velocity ratio and also mechanical advantage. So, when we say mechanical advantage, okay, mechanical advantage, okay, which is the MA. So, mechanical advantage, this is the ratio of what? The load to what? Effort. Okay, so which means the formula is mechanical advantage is equal to what? Load over what? Effort. Like that. Or sometimes you can just say L over what? E. It has got no units. It is just what? A number. Like a number chart like that. Then we come to what you call velocity what? Ratio. Velocity ratio. So velocity ratio VR. Okay, this is the ratio. This is the ratio of the distance moved by the what? Effort to distance moved by the load. So meaning that VR is equal to what? DE over what? DL. Like that. So distance moved by the, so we can say maybe distance moved by effort, okay, over the distance moved by the what? The load. Which will give us VR is equal to what? DE over what? DL. Like that. Now, having said that, there's something that I want to explain. Let me use this board here. Okay, was that one? Double. Watching me up a man, yes? Oh, I'm gentle. Esther, you're able to see it? Okay, now using this board here, when I use this board here, okay, now I'm a valid board. I want to explain about the velocity ratio. I said the velocity ratio is equal to what? Distance moved by the what? Effort over distance moved by the what? Load. Now, when it comes to velocity ratio, it's totally different when it comes to pulley what? System. For pulley system, VR is equal to what? Number. Is equal to number of what? Wheels. A number of wheels is equal to velocity what? Ratio. Suppose you are something like this. Kwa akena mkakwela. Then apa, then we have something like this. And then another one comes down there. Then there is the load there, which means the load here. Then mkakwela hapa, then we'll come back. What is the velocity ratio of this pulley system? So what did I say? For pulley system, velocity ratio is equal to the number of what? Wheels. So that means that velocity ratio in this case is what? 1, 2, 3, 4. So velocity ratio is equal to what? 4. That is under pulley system. That's what you do when you're finding under pulley system. So VR is equal to number of wheels. And then when it comes to inclined plane, that is where now we're coming to use the what? The formula. Kind of going to have inclined plane in this manner. From here up to there, you can have the distance that maybe let's say 40 meters. Then I go by the castle. I got an airport, then from there up to maybe 10 meters. Can you find the velocity ratio? So we're saying VR is equal to what? Distance moved by the what? Effort over distance moved by the what? Load. What is the distance of the effort? Is what? 40. Over the distance of the load is what? 10. Which means you get what? 4. Again, if it's just a number, we're not going to have units to say maybe 4 meters or anything like that. No, we're just going to have a number in that manner. And then for gears, the difference for the gears is that you're going to count the number of what? Teeth maybe there. I just use the one which is there on the board. For gears there, it is equal to the number of teeth. You just count the number of teeth that are there. For example, maybe Apawanga Kambat, okay, this one has got what? 12 teeth. Then you have Kambat Shani, 36 what? Teeth. Can you find the velocity ratio? So you just say VR is equal to what? Number of teeth. Number of teeth in the what? Driven. Number of teeth in the driven what? Gear over the number of teeth in the what? Driving. Which means VR is equal to how many teeth do we have in the driving gear, the bigger one? 36. Divided by how many teeth do you have in the driven gear? The driving gear? 12. Which means VR is equal to 12 into 36. We get what? 3. We get 3. So again, we cannot say 3 teeth. No. Again, like I said, both the velocity ratio and mechanical advantage have got no what? Units. They are just the ratios. The ratio has got no units. Then the last one is what we call efficiency. So efficiency, okay. So for efficiency, EF is equal to what? Mechanical advantage. It is the ratio of the mechanical advantage to velocity ratio expressed as what? Percentage. Like that. So a question will come where you'll be told, can you find the efficiency of a certain machine? Can you find what? A question comes like that. So maybe I'll give you a question somewhere, maybe after writing there. So just write, then I'll give you a question, then so that you see how questions come. So this question was saying, the diagram below shows a pulley system of effort 300 newtons and a load of 600 what? Newtons. Then the question comes to say, find the velocity what? Ratio. What did I say about the velocity ratio for the pulley system? Velocity ratio of the pulley system is equal to the number of what? Wheels. So mean that VR in this case is what? 1, 2, 3, 4. So velocity ratio is what? 4. Every time you are given a pulley system, the velocity ratio is always 4. You just count the number of wheels or the number of ropes. Apa palituma ropes 3 apa pakati. 1, 2, 3, 4. Nishinje velocity ratio. Then mechanical advantage. What did I say about mechanical advantage? So we said mechanical advantage is equal to what? Load over what? Effort. Okay? Then mechanical advantage is equal to, what is our load? Our load in this case is what is 600, right? Divide by, what is our this one, this is sorry. This one is 200, sorry. Okay, so our load is what? 200. So that our mechanical advantage is 200 into 600 is what? 3. Again, there is no 3 newtons. It's just 3. There is no units when it comes to these guys. No units. To leave it like that. Then we come back to efficiency. So efficiency, according to the formula by Papa, efficiency, we said efficiency is the ratio of the what? Mechanical advantage to velocity what? Ratio expressed as what? As a percentage, which is 100. So which means MA over VR multiplied by what? 100%. Which means what is the mechanical advantage? Mechanical advantage is what? 3. So we have 3 over what? 4 multiplied by what? 100%. Which is 3 times 3, 3 times 100 is what? 300 what? Percent divided by 4. Which means how many times can 4 go into 300? Time is what? 7, which is 70 what? 75. 75 what? Percent. So the efficiency of that machine was 75 what? Percent. Sometimes the question can come to say, why is the efficiency of the machine not 100 what? Percent? Because the efficiency of the machine is not 100% because some what? Energy. Some energy is what? Used. There's energy loss. Some energy is used to what? To overcome. To overcome what? Friction force. Friction force. Or there is energy loss because of some energy what? Loss due to friction loss. Or because of energy loss due to friction. Or friction what? Force. Those are the questions that you ask me. I'm sending you questions.